Okay, so this is the same thing for those that are going to be watching the recording, whether Math 2100 or 2110. So the first topic that you have here is analytical geometry, and you talk about conic sections, the shape. So the first shape you have is a circle. So you have a circle. We'll talk about it in details. We have a parabola, and we have an ellipse, and we have lastly we have a hyperbola. For now you just learn up to a hyperbola, but there are other cases you're going to learn when you do vectors in 3D. Yeah, but for now these are enough. And these shapes come about as a result of cutting a cone in a certain way, or rather at a particular angle. And there's a general equation that we're going to be using to identify these conic sections. So the general equation that you have is as follows. So the general equation we'll be referring to is simply ax squared. You have this plus bxy, then you have plus cy squared. Now for you to turn this equation to a particular suitable equation to represent any particular conic section, you need to remember that part for completing the square. Yeah, so we're going to give some geometric definitions of how a circle equation is going to be different from a hyperbola one, a parabola one, and lastly an ellipse one. So start with a circle. Let's exhaust everything we can about a circle. So when you talk about the circle, you know it's anything that has a well-defined shape in terms of having a radius. The equation we're going to be starting with, the normal equation. If a circle is at the origin, so this is with reference to the origin, 0, 0, obviously you know a circle is going to look like this. Let's say I have something that looks like this. There's a distance from the origin to the circumference, so this distance is your r. So the general equation would have been x squared plus y squared is equal to r squared. That's the general form of an equation at the origin. But the general equation that we are supposed to use, the general one, is x minus h squared plus you have y minus k squared is equal to r squared, where r represents the radius. So r is the radius, and h comma k is simply the center. Yeah, the center of the circle that you are given. Yeah, so this is like the standard one. Then this is like the general one. Of course, some people would prefer expanding this equation to something that looks like this. When you expand this, you know how to expand this part here. So you would have to get x squared, multiply these two, so you get 2hx. You have plus h squared, then plus y squared. They'll just prolong it rather. This is going to be 2k y, then plus k squared is equal to r squared. Yeah, then they'll move the h squared and the k squared on the other side. Yeah, then obtain a general expression, or rather move the r squared on the other side, so that there's just a 0 here. Maybe for the sake of just us being able to solve this, the equation would have been x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared, then minus r squared is equal to 0. So some other people say this. It's the same thing as this guy here. It's just a general equation. Yeah. So this equation is very important because it can work for anything. So let me give you an example. And this is one of the simplest conic section you ever deal with. So here they are saying, I'll just read the question. They're saying find the equation of the circle with a center. The center is 1, -3 and passes through the point 1, 0. So passes through a certain point. This is the point we're dealing with. This is your x and your y, and the center h, k is this. So now they want the equation to this particular equation. I mean to this particular thing here. Now remember we have a general thing. Remember we have this. There is the one I gave you, which is way simpler. there is x minus h squared plus y minus k. This gives us r squared. So to get the equation, we just have to find what the radius is. So x, I'll use the 1. So any point, x and y can be any particular point where the circle passes through. Because the distance from the center to the circumference doesn't matter where the circle is. So let's say this is your center. The distance here is the same as the distance there, right? So any point, that's the x and y. They can be any. The fixed thing is h and k and the radius. Yeah, so we're going to put 1 wherever there's x and 0 wherever there's y. Where there's h, we'll put 1. Where there's k, we'll put -3. So be careful with the negatives here are already in the equation. We just have to plug in the x and the y, the h and the k. So I'll put 1 where there's x minus, my h is 1 as well. I'm just trying to get the radius first. Y is 0 minus -3 squared is equal to r squared. This is going to be 0 plus this is going to be 9 r squared, meaning my radius is a 3. Hence, the equation is equal to x minus, that's going to be 1 squared and plus y minus -3. This is squared is equal, the radius is 3. So I'll just say 3 squared, that's a 9. You can finish it off by leaving it just right here. Y plus a 3 is equal to 9. So this is the equation with the above information. So just at this point here, before we progress and I give you another problem, another example rather. Is this okay, Charles, here? Okay, so let me do another example. So another example I'm going to give us is they're saying find the radius. So example 2, they're saying find the radius and center of a circle whose equation is 9x squared then plus 9y squared minus 18x then minus 36y plus a 44 is equal to 0. Now here at least things are easy because they said it's a circle, right? They said find the radius and the center of a circle. When it comes to quizzes or assignments or tests rather, they won't be saying or stating the shape of the conic section you're dealing with. They'll just give you this general equation, this type here, this, I'm sure I remember this, the first thing I mentioned here to say the general equation for any conic section is this guy. They'll give you something like this. Now it's up to you to resolve it. I had mentioned to say you need your skill for completing the square, the one you had you got in 1100 in first year, so that you're able to change this equation that you have here. So here we're going to gather all the terms that have x separately. Yeah, so I'll start by getting this part. I'll get my 9x squared minus 18x. Then I'm also going to get my 9y, everything that has y as well, put them close to each other. Take the constant on the other side. Yeah, so here our constant is 44, goes on the other side, becomes a -44. Then from here, I'm completing the square of this portion alone. Let me put it in brackets. There's this portion and there's also this portion. I'm completing the square of both portions separately. So the first one, I'll factorize a 9 outside. So 9 goes outside. I'll remain with x squared minus what? A 2x. Same applies here. I'm going to have a 9 outside. This is a y squared minus a 4y. This is equal to negative what? 44. Yeah, then from here, I'm going to have 9. So here I'm going to have, just say x, there are these brackets. I'm going to have x, then minus half of 2 is 1, then minus -1 squared. Yeah, then here again I'm going to have a 9, and then these big brackets, there's y minus 2 squared minus, then there's a -2 squared. Then there's a negative 44 this side. Are you okay up to this point here? Is this okay? It's okay, all right. Yeah, then from here, I can have my 9. This is x minus 1 squared minus 1 plus my 9, y minus 2 squared minus a 4, negative 44. Then this is going to be 9 x minus 1. I'm just multiplying 9 by everything. Then again, I'm going to have my 9 y minus 2, my 36 there is equal to negative 44. Then we can take the constants on the other side, so that we just have 9 x minus 1 squared plus 9 y minus 2 squared is equal to negative 44 plus 36 plus a 9. Because I'm taking this number on the other side becomes positive, my negative 36 becomes positive on the other side. Then from here, I'll just have 9 x minus 1 squared plus 9. Then I have y minus 2 squared is equal to, if you sum up this, that's 36 plus 9. That's going to be, what is it? That's going to be 15. That's going to be 5 remainder 1. That's 45. So there's going to be negative 44 plus 45. That's just a 1. So now I'm having 9x minus 1, y minus 2. This is a 1. I divide by 9, divide by 9, divide by 9. Implying that I'm having x minus 1 squared plus y minus 2. This is 1 over 3 squared. So my radius is 1 over 3 and my center is simply solve what's inside here. Yeah, so that's going to give you 1. Solve what's inside there, that gives you 2. So this is our h comma k, that's the center, and this is our radius. Remember, these are supposed to be radius squared, right? Which is 1 over 9. That's the reason why I've square rooted 1 over 9 to give me the 1 over 3. Is this okay here, Charles? It's okay? Hello, Charles, are you able to get me? Charles, any questions here? Or it's okay? Okay, so if you're okay, let's continue. So I'm going to give you a simple exercise if you're okay with this part. Yeah, so the next question I'm going to give you is the task. So I'll give you every conic section I'm going to teach you, I'm going to give you a task to see if you really understand. Yeah, so the task I'm going to give you is here. I'm just going to write it here. Find the equation. Yeah, so find the equation of the circle passing through the points negative 1 1, then you have 4 comma negative 4, and another point there is a negative 4 comma negative 6 comma negative 4. Yeah, so you just try this, then you show me on WhatsApp. You show me what you're going to get. You can just take a screenshot, where I can see you send it on WhatsApp. Yeah, so I can see you send it on WhatsApp. Okay, so let's go to the next part so that we don't waste time. The next conic section I'm going to explain is the parabola. Now this is familiar, so conic section number 2 is the parabola. Now this is something that you looked at in 1100 as well. The only difference here is that we just introduce a few things that you're going to be talking about. So a parabola is just a set of all points in a plane that are equidistant from a particular line, a fixed line, that is going to be called a directrix. Yeah, so if I may explain it using something you are already familiar with. So let's say you have something that looks like this. Let's say you have this. Yeah, this is the same thing as x squared. The function f of x is equal to x squared. Those quadratic equations you used to have, those are parabolas. Yeah, so here we're just calling them parabolas, but they're still the same. Yeah, so if you have this type of expression that you are given, then let's say there's a line. Let's say there's a line here. Let's say this line is supposed to be bored. Let's call this line, let's say y is equal to p, for instance. Yeah, we just say there's a point from the vertex. This point here is called the vertex, where the whole thing is turning from. Or rather, we can just call it the turning point. Yeah, so there's going to be a point inside the parabola or the quadratic equation. So in this case, since we are placing the vertex on the y plane, the y component is what? I mean, the x component is 0. Then the y component is going to be called p. Let's call it p. So this is called the focus. There's going to be a point that we call the focus point, which is equidistant. So the distance from the focus to the vertex and the vertex to the directrix has to be the same. This distance is supposed to be the same as this distance there. Yeah, that's basically what we assume. Now, for lack of instead of me illustrating everything, let me just give you how the equations are going to be given, because a particular parabola can have 4 cases. Yeah, so the 4 cases that you're going to be given for a parabola are when we have something that looks like this. So let me just, it can either look like that, it can either be facing down. Yeah, then it can also be here, it can also be this side. Yeah, so these are the 4 cases that you can have for a parabola. Yeah, and the equations you're going to be dealing with, so for simplicity's sake, I'll just like summarize them and put them here. So it can either face up or face down. Yeah, so let me give you this case, and also let me combine this case. So these are the 4 cases you may have, and whenever it's on the y-axis, the equation can either be x squared is equal to 4py, or it can be x squared is equal to negative 4py. These are the 2 equations. So this is when it's positive, this is when it's negative. These are the 2 pairs of equations for these 2 cases. Then whenever it's like this, meaning you have y squared, when it's positive, on the positive x-axis, this side, meaning you have negative, we have 4px. Then if it's on the negative side, you can have another equation, which is y squared is equal to negative 4px. So p is going to represent what we call the focal length. The focal length is simply the distance from one end of the parabola to the other end passing through the focus. So this distance from here to there, this is what we call the focal length. Yeah, that's the p that we are having in these 4 equations. So it can only be gotten from the equations. This p that we are having there. Yeah, so that's the focal length, the value of p. Then, so let me just say, there's a focus, the terms you're going to be needing here to know. There's focal length, then there's directrix. Directrix can either be, so for these cases, for this type here, let me use red, the focal length, the directrix is y is equal to p. For these cases, for this part, the directrix is x is equal to p, because it's it's lying on the x-axis, so either the directrix is here because it's a upper line, so you see that if it's facing like this, meaning x is equal to something. Yeah, remember the definition of our directrix, the position that is placing the vertex to be equidistant between the focus and that particular point. So this is supposed to be the same as that. Yeah, I'll give you a proper example. So those are the 4 cases you need for a parabola. Then there should be something else that I must mention. Yeah, is this okay? Yeah, I think that's okay for this part. Let me just give you an example. Okay, yeah, for now I think this is okay. Let me just give you an example for a parabola. The example here says, find the focus and directrix for each of the following parabolas and sketch the graph. Yeah, so I'll give you all the 4 questions that are here. So y squared is equal to negative 9x. Then for B, you have x squared. Okay, these 2 are going to be enough. Then the other 2 will be yours to handle. So I'll solve this. This is going, so you just look at the one that has a squared is y, right? So meaning this thing is going to be the second case, meaning it will be like this. Yeah, it will be this. It either turns on the other side. Yeah, so this, look at this pair here, the one I gave you, meaning it's either here or it's there, whenever y is the one having the squared. Then whenever x is the one having the squared, meaning it's like that one you used to learn in 1100, either turning up or turning down depending on the coefficient. Yeah, so it's turning down when the coefficient of a, remember I used to say the coefficient of x, this guy, plus bx plus c. When it's negative, it turns down, right? Yeah, then it's smiling if it's positive. Yeah, so I've given you both cases. Yeah, I'm going to solve both. So we need to find the focus, the directrix, and then sketch. Yeah, so C, these are going to be yours. I think I can pick one from here because they have fractions. People hate fractions. It's just the same thing though, but I'll solve one from here. Then there is this one here, 7 y squared is equal to 0. This is supposed to be a y. One of these has to be a y, so I'll make a y here. They made a mistake, so I'll pick this to be y. Yeah, so I'm going to do C, and I'm also going to do A. Okay, so you want me to do C and D. Okay, it's okay. Let me do C and D. Yeah, it's one and the same because we'll turn this. Okay, so I'm going to do C and D. Okay, so for C we're having something that looks like this. We have x squared. This is equal to negative 4 over 3. Then I've put a y there. Yeah, so I should mention that in as much as I gave you these equations to be the 4 general, these are like the standard equations, because we're assuming that it's either on the x or the y axis. It's not always going to be the case. Sometimes it can actually just be hanging in the air like this. So all these equations here have general versions, so to say. Yeah, so there are times when it's just hanging. Let's say it's just here. Yeah, so it qualifies to be this case, but it's hanging right here. It's not on the axis. So in this case, we're going to have, so each of these equations can have h and k as well, or rather people say c and k. So for the parabola, the h and k represents the vertex, the turning point where it's turning from. Okay, but I'll give you an example for that. These questions here are simple because they are from the origin. So if this is what we are having, look at the guy that has the squared. This is what, this is the same as, I'll just make life easy for you and change this. Yeah, so I'll start with, first of all, cross multiplying with a 3. That's going to give us 3x squared is equal to negative 4y. Yeah, then this here is going to be the same as, I can divide by negative 4. I just want you to see something, to say this is not different from what you learned in 1100. This is technically just a quadratic equation. So this is what you are having. This is the equation. I've just changed it to make y the subject. Then from here now, you can just come right here. and try to sketch it. So you know, because the coefficient of x squared is negative, you know this thing is facing down, right? Yeah, this thing is actually passing here. It's passing right here. Where we are passing right here on the origin. It's actually here on the origin. Yeah. And we need to have the focus there. There's 0 comma something. Yeah, 0 comma something. We need to find that something, the p. Then there is a y is equal to p right here. Yeah, right? Y is equal to p. So how do we get to solve for our p? So this equation is going to mirror which equation? So I'm just going to write this. Negative 4 over 3 y should have been x squared is equal to negative 4p y. Yeah, so I'm going to get this part and equate it to this part. That's going to be negative 4 over 3 y is equal to negative 4 py. Yeah, so these two parts here, they're going to give me what? If I cancel the negative, this is, and cancel the y, so I'm going to get 4p is equal to 4 over 3. I divide by 4, meaning p is equal to 1 over 3. Right, so this here is negative 1 over 3, and this line here is 1 over 3. So my vertex, we know it's at the origin, the vertex is 0, 0. The directrix is y is equal to 1 over 3, and the focus is going to be 0, negative 1 over 3. Is this okay here, Charles? Can you look at what I've done here? Is this making sense? Do you need me to redo it? So here I was saying, for these cases, like these questions I've given you, it's 0, 0, yes, for the vertex. But they can be generalized. These equations I'm from giving you, they can be generalized. Sorry, this is another class I was representing. Okay, so like these equations like this, whenever you see this, because I said there are 4 of them, right? Negative 4py. So this can be generalized. This is when it's 0, 0. This is like the standard equation, like how we had for the circle. Remember, for the circle it can be this, meaning it's 0, 0. But we had another version which is x minus h. So even here we can have another version which is x minus h squared is equal to, there is 4p, then there's y minus k. We can have this version as well if it's not at the origin. Same even here. So each of these equations, so we're just going to deal with the standard, but there can be another version. Yeah, that's why I say the general formula always has to be worked out to know which conic section you are dealing with. Yeah, so we can have this version as well. Is this okay here, Charles? I'll give you examples for the general case, but for these ones, these questions I've given you, yes, the vertex is at, whenever you see x squared alone and y alone without subtracting anything, just know to say it's at the origin. You are understanding, right? Yeah. Okay, thank you. So we can proceed to D. So you wanted us to do D as well. Yeah, so treat it. So try by all means, whenever you learn something here in 2110 or rather 2100, you relate it to anything from 1100, from first year. That's when you realize that this is actually just a build-up. Yeah, just new terminologies and new concepts, but they have to be coming from somewhere, which is your prerequisite, your 1100. So here, number D is equal to that. So what has the squared here is y. So it's either this can be 4px or should be y squared is negative 4p x, right? Meaning it's what? Meaning it's either facing here or facing there. That's what you should have in consideration whenever the guy having the squared is what? Is y. So any of these two cases. So now we're going to make y squared to be the subject of the formula here. So we're going to have negative 7y squared is equal to negative 5x. Divide by negative 7, divide by negative 7, meaning y squared is equal to this. So you notice this is when it's facing on the positive side. From the general case, this guy, right? So equate these two. Y squared is equal to 4px. So equate this part to this part. That's going to be 5 over 7x is equal to 4px. So from here, you can cancel the x, meaning 4p is equal to 5 over 7. Then divide by 4, meaning p is equal to what? This is going to give you what when you're dividing? It's going to be 5. 4 by this is what? Is it 28? Yeah. So meaning you're getting a 5 over 28, implying that that's your p, right? Yeah. So if this is what you're having, so we're having something like this, or this is supposed to be at the origin. Sorry, this has to be here because our vertex is 0, 0. So the p is here, which is what? 5 over 28, 0. That's a focus. And the directrix is just right here, which is y is equal to negative 5 over 28. So this is how we're supposed to answer D. Yeah. Is this okay here, Charles? Okay, so when it comes to an ellipse, so an ellipse is like it's like in egg form. Yeah, so this is just a set of all points in a plane whose distances are fixed from two particular points, f1 and f2. It has two focuses. Yeah, so this is just like how the shape of an egg is. It was supposed to be a circle, but then it's not a circle, so it looks like this. Or it can be on the y-axis, so it can have two forms. Yeah, so now you have to notice that the distance here has to be long. This is long. So this is, let's say this is our focus f1, then this is our focus f2. So the distance here can be called A. Yeah, so this is going to be called A. The longer distance is always going to be called your what? Your major axis, so to say. For lack of better terms, I'll use those. So we have like the major axis and the minor axis. So there's a longer side. Yeah, so like this part is long. Yeah, then this part here is a shorter side. So this is the distance from here to here. This part here is B, is called B. So these two my distance are B. Then these two my distances are AA. So same applies here. This distance would be A. Then this distance will be negative A. This will be negative B. Then this will be B this side. Yeah, so let me give you a proper, let me try to give you something. Let me try to open the notes so that you can see it clearly.
Yes.
So this is the shape of your this is how an ellipse looks like. Yeah, it's supposed to be a circle, but then it's not. It's like squeezed, just like an oval shaped egg. Yeah, so there's always this longer distance. This distance here, the longer one, the axis, which is called the major axis, will have these coordinates here. We'll say A and negative A. Then the focuses, you always have two. They are supposed to lie on the major axis. So there's also going to be a negative and a positive. Then there's a minor axis. This has to be B. This has to be negative B. Yeah, so this is what you need to have in mind whenever you think about an ellipse. So now this thing is going to be a little bit interesting because we're saying, according to the definition, we said it's a set of all points in a plane whose distance from two fixed points, f1 and f2, is going to give us a constant sum. Yeah, so we're saying if you pick any point, let's say P here, and draw a line there, and draw another line from f2 there, the sum, like E distance here up, when you add it with this distance, it's going to be the same even if you were to pick another point. Let me use green. Another point, let's say here. If you add this distance and that distance, they'll still give you the same. Even if you pick another point there, add this distance and that distance, they'll give you the same. Even if you pick a point there, the distance from f1 to f2, the summation of this distance and that, they'll give you the same answer. That's what makes an ellipse to be so special and interesting. That's the reason why we have it. Yeah, so now the proving is a little bit unnecessary, so I'll just go straight forward to give you the general equation when it's lying on the x-axis. So there are two things here that you're going to get. It's either it's on the x-axis or on the y-axis. Now we're talking about an ellipse. Yeah. So when it's on the major axis is on the x, so if I give you something like this, if the longest side is on the x-axis, meaning it's like this, the following are the informations you need. So the equation, the standard one, is either going to be this. So this is what you get. Y squared then b squared is equal to, there's a 1 this side. And please have it in mind that a is always bigger than b. So how do you know it's on the x or the y without even the drawing? Just look at the equation you're having. The one that is bigger, the number ikulu kunyansi, meaning that's where it's lying. So if b was bigger than this, let's say I give you x squared, and I give you what, 25, then plus y squared, then I give you 36. Between these two, our a is going to be 36. That's our a squared. So that our a is what, 6, because b has to be smaller. 36 is bigger than 25. So meaning it is going to lie on the y-axis. The letter that has a bigger number down is the axis that we're going to have. So this is going to be on the y-axis if it was like this. But we're saying for a normal case that lies on the x-axis, the number down, or the number which is the denominator of x squared, is supposed to be the bigger number. And whenever that's the case, it means that the focal axis is going to be horizontal. Yeah, so it's going to be like this, the focal axis, like the focal length, where the two focuses are, or foci. When they're plural, we say foci. So F1 and F2. So it's going to be horizontal. So F1 and F2 will lie on the horizontal line on the x-axis. Yeah, whether we say x-axis. That's one thing you should know. Then the foci, F1 and F2, are either going to be plus or minus c, 0, because they are here on the x-axis. Negative, positive. Y is 0 for something that lies on the x-axis. Yeah, then the major axis. The major axis is going to be on the x as well. Here, that's going to be the major axis. The minor axis is going to be like this. So here, we'll just say this is going to be 0, b. Then that's going to be 0, negative b. Then here, we're going to have a, 0, and we're going to have negative a, 0. So these are the vertices, like the turning points, the turning point here, the turning point there, the turning point, yeah, the places where touching x and y. Then when it's lying on the y-axis, it's just the same thing, just flip it. So everything I've said here, just flip it. So meaning here you're going to have 0, plus or minus c. This, just flip this. Then even here, meaning a is under y squared and b is under x, because a always has to be bigger than that. So just for the sake of us having it here, I'll just plug it there. So you have something that looks like this. This is your a, 0, a, mean 0, a, because we're on the y-axis. This is 0, negative a. This is what, b, 0, and this is what, negative b, 0. We have the foci there, f1, and then we have f2. It's just the same, just that we're having y is the one having a. Yeah, then this has this, because a always has to be bigger than b. Yeah, so that's what you have. So these are standard expressions. I can give you a general one, whether the above one, this one here, the one I gave you, it has a general one as well, when the center is not at the origin. So all this, we're talking about them from the origin point of view. But when they're not at the origin, the equations would have been x minus h, then squared, over a squared plus, then y minus k squared, then over b squared is equal to 1. Yeah, the same applies even this guy down. It can have a general equation, a general expression. Again, it simply means you're going to get what? Is it your y? Let's say k again. I'll say k for the sake of being consistent with the letterling. Then this is x minus h. Then b squared is equal to 1. Yeah, so no wonder the general equation I gave at the beginning is very important, because we're going to be turning it, translating it. That's what translation is all about, or rather rotation axis. changing the general equation so that you are able to identify the type of conic section that you are given. Yeah, so let me give you an example here. At least it's better because we're looking at each conic section separately. So even when I give an example, you already know to say, okay, we're dealing with an ellipse, so it has to be an ellipse. Yeah, but then in assessments, or rather when you look at your terror sheet, they'll just give you a general equation. It's up to you now to determine, and there are ways to do that. Yeah, so let me give us an example here. I'll give you two. Yeah, I'll give you two. Yeah, so these are going to be very sufficient. Then one is going to be an exercise. So there's x squared over 25 plus y squared. There's a 9 is equal to 1. Then b, there is 4x squared plus y squared is equal to 1. So this is question 1. This is what I'm going to do, these two. Yeah, then question 2 just says find the equation. Okay, no, I think I have them here in your notes so that I don't waste time. I think I have it here, just right here somewhere, I think. If these are student notes for, okay, these are not the same as the ones for last year, okay. Find the equation of an ellipse at the origin, whose center is at the origin with focal axis, with a focal axis 5 distance. This is 1 unit. Okay, so with let's say this, they're saying with vertical focal axis to be what? At the origin with the focal axis, if semi-major axis is 5 and the distance between the foci and the vertices is 1. Okay, so let's say with what? Minor axis to be 5, minor axis to be 5, the distance. Okay, so I'll still send a screenshot on WhatsApp in case you're unable to get it, you read it for yourself. But yeah, distance between the foci is 1 unit. Yeah, so I'll still inbox this on WhatsApp as you send it. Yeah, okay, so let me solve A and B. These guys here, these are the typical exam standard questions you see. If you check any paper, you see these type of questions. Yeah, so let me just solve this part. So yes.
Yeah, concerning how to identify, for example, it said when x squared, when a is big, supposed to what? X-axis, right?
When what?
On top. When a is big.
A
is greater than.
Yes.
Supposed to be x-axis or y-axis.
Yes, so you look at the... So the one you call A is the bigger one. Yeah, so when you look at your numbers, let me just say, like upper, so like look at this here, Charles. So the one that is going to be A is 5, because 25 is bigger than this. This is like just like 5 squared and 3 squared, right? So the bigger one is the one that you call A all the time. It doesn't matter whether it's under X or under Y.
So how do I identify that this is line X-axis or Y-axis?
Oh, the one that has a bigger number. So like upper, so x squared is the one having a bigger number. So it will lie on the x-axis. Yalawa, the major axis will look like this. Yeah, so you look... Pardon?
It's the bigger number of 9.
So if the bigger number, let's say it was x squared over 4 plus y squared over 9, meaning so the bigger number is 9, so iyalaba a, meaning it's under what, y, so meaning the major axis is going to be y axis.
And 9 is supposed to be there.
Yes, and 9 is going to be a squared, so that our a becomes a 3. Then this is b. B is supposed to be 2, the square root of 4, which is 2. You get it now, okay? Yeah, so let me just solve this example. You see how we get to simplify it, yeah? So that, yeah, you get familiar with this. So I think because of time, I'll just end on explaining parabolas, then we'll end parabolas here, but we'll have to finish this whole topic this week. So tomorrow we'll do eccentricity, translation axis, rotation axis, I mean. Then we'll also talk about the discriminant test, then parameterization, polar coordinates, then we're done. This is where the topic ends. So yeah, we'll finish it tomorrow. So today I'll just end on hyperbola, just describing it and how to sketch it. So here, on this example here that we are trying to solve on the ellipse, so just do this one here. So solution, yeah, so the solution that we are having is x squared over 25, this is plus y squared over 9 is equal to 1. So already from here you're able to tell a squared is equal to 25, meaning a is equal to 5. Then you're saying b squared is equal to 9, meaning b is equal to 3. So like I said, the bigger number tells us the axis we're dealing with. So the major axis here, so you say x-axis is the major axis. This is the axis we're dealing with. Why? Because a always has to be greater than b. Yeah. So our a is 5, meaning the turning point here is 5. Same applies there. The turning point is 5. So we need to have something that looks like this. Yeah, that's what we need to have. Then we need to have what? We need to have b. This is 0, 3. Then this is what? This is supposed to be 0, -3, right? This guy here down. Yeah, this has to be 0, -3. 0, -3. Then I should have mentioned to say there should be a formula that we use to get our foci. So here I should have mentioned to say on all these two cases that we are having, there's a formula that we need to know, which is that a being the longest side, so a being the longest side, it's equal to b squared plus c squared, because we need c for the foci. Yeah, so we need to find this point here. Where are we touching? Here, and where are we touching there? So we're going to get our a being the longest side, which is what? 3, is it? Or 5. So 5 squared is equal to b plus the c that we don't know. That's going to be 25 minus 9. That's going to give us 4. 16, man. 16 c squared. Then now with square root, so c is equal to 4. So meaning here we're going to get -4, 0. Those are the two foci. Then this is 4, 0. Yeah, so the foci, just say plus or minus 4, 0. The vertex, the major one, there's a major and there's a minor. So major is what? Major is plus or minus 5, 0. Then say minor vertex, that's going to be 0 plus or minus 3. Yeah, so end here. These are the only things that were needed. Is this okay here, Charles? Is this okay?
Yeah. Clear.
It's clear, huh? Okay, let me do the next example, the one that has a fraction. Yeah, so this one is very, very easy. And this one here, we're going to get what? This is, they're saying 4x squared. They were saying this part B was 4x squared, then plus y squared is equal to 1. So I'm going to divide both sides by, I'm going to divide everything by the number which is here. So like our pali 4, pali 1, okay? So to make things fair, I'm going to multiply 4 by 1 so that I get to a 4. So 4, even here 4, even here 4. I don't know, should I do this side? Do we have to do this? How can I say this? Because the formula works when there's a 1 on the other side, right? That's the only time the formula works. So here, how can I say this? Because we need to make this guy here to be a 1. The coefficient. Yeah, the coefficient here has to be a 1. So let me say this. Yeah, what I was thinking is actually right. So here, for you to be able to make, the condition is that x squared and y squared, they have to be carrying 1s. Like the coefficients have to be 1s. So the best way to do it is by dividing with the expression that you have. Like, how do we make this to change? How can I say this? If you have, let's say, this part here, let me just go direct. You guys are senior, so you'll be able to understand this. So this, we divide by the reciprocal of what's here, because that doesn't change anything. It can still go back to being a 1, I mean to being 4. So I'll divide by 1 over 4. Right? This is, so we'll change this. So we'll change this whole thing here the same as having a 4 already. So I'll just write this rather. So I'll write it like this. This part is going to change. This is going to be the same as x squared over divided by 1 over the number which is in front there. That's a 4. Plus, then there's going to be y. There's a 1 there. So we're supposed to divide it by the reciprocal of 1, which is the same as 1 still. That's how we maintain this side, because this has to be preserved. The 1 here is preserved as a standard, in the standard and in the general equation for an ellipse. So this has to be preserved. So we divide by the coefficient. Because if you divide here, it's like there's a 1 here now, right? So, but if you say 1 divided by a quarter is going to give you what? 4. So we haven't changed anything. All we want is that we don't want to see anything in front of x, and we also don't want to see anything in front of what? Y. That's the reason why we're doing this. So in short, your equation is now x squared 1 over 4 plus y squared over 1 is equal to 1. So this is what you have. So let me just, before you ask me any question, if I had 8x squared plus 7y, and there's a 1 here, you would have divided this by, you would have changed this to be x squared over 1 over 8 plus y squared over 1 over 7, then is equal to 1. Are you getting this here that I'm doing here, Charles?
Yes.
So this is what we would have done if we had any other numbers. So we didn't have any number in front of y. So even me just showing 1 here is just for you to be able to see when I say my a is going to be 1, you agree with me. Why? Because a squared is equal, the bigger number between 1 over 4 and 1 is what? Is 1. So I need to write 1 there, then find the square root, meaning a is what? 1. Then b is supposed to be 1 over 2 because of the square root of this. So b squared is supposed to be the smaller number. Then I'm finding the square root. That's where the 1 over 2 is coming from. So that you're able to tell that we are lying on the y-axis, because we say the number which is big will determine the major axis. So this ellipse is lying on the y-axis because the bigger number, which is 1, is under y. That's the reason why we're saying it's going to be on the y-axis. So that's the whole point here. So we're going to write this as so just for simplicity's sake, I'm going to go with x squared 1 over 4 plus y squared over 1 is equal to 1. We said a is equal to 1, b is equal to 1 over 2. And remember, there's a formula that we said a squared is equal to b squared plus c squared. So we use this to find our c, because we need it to get our foci. Our a is 1. This is 1 over 2 squared. We're looking for c. That's going to be 1 minus 1 over 4. This is going to be c squared. Then that's 3 over 4. This is c squared, meaning c is equal to root of 3 over 2. Yeah, so now we are having what? We are having we're having this guy here. Let me just draw it here, because you have to always sketch it. It's easier for you to see it. It's lying there, something like this. This is 0, 1. This is 0, -1. Making sense, because b is what? B is 1/2, yeah. So it's 1/2, 0, -1/2, 0. The foci has to be less than 1, -1, so there's a -1. There's a 0, -√3/2, and there's a 0, √3/2. So yeah, this is what we have. The vertices, the major vertices, the minor vertices, and the foci. Is this okay, Charles? Is this okay? Okay, so this this guy helps, this part that we've done here. Now, in an event where the equation would have been general, meaning the origin wouldn't have been our reference point, would have had other cases. So I emphasize to say you have to always look at the general and the standard equation whenever you're given a particular conic section. Yeah, so the equation would have been x minus h squared, then over a squared, plus you have y minus k, then over b squared is equal to 1. Whenever there is an ellipse you're dealing with, there should be a 1 on the right hand side. We always emphasize to make it a 1. You'll see in the other tutorial sheet questions we're going to deal with. Yeah, so that's basically an ellipse. There's a question I had given, a task. So now we look at the last conic section, which is a hyperbola. So a hyperbola is very interesting because it's like you have two parabolas given together, and these two parabolas that you are given together have asymptotes connecting them, and they can only be in two forms. It's either you have a case that looks like this. This is a parabola, so you can either have this asymptote here and this asymptote there, or you can have a case where your question looks like this. You can have these guys here. Yeah, so a hyperbola can take any of these two forms. Yeah, and they also have a major axis. How you know the form that it's going to take is dependent on the major axis. Yeah, so let me give us a general form for a hyperbola. So whenever you have, how can we say this? Whenever you have, if a is under, so it's like this, meaning you're going to get x squared over a squared minus y squared over b squared is equal to, there's a 1 this side. You notice there's a minus here, right? For a hyperbola. For an ellipse there was a plus, but here there's a minus. Then here you get y a squared minus x, then you have b squared is equal to 1. Here it doesn't matter the relationship between or rather a and b. We're just saying the guy that's positive is going to be your a. Yeah, that's what we're basically saying here. The guy that's positive. So here our y is the one that's positive. Then b is the denominator of x squared, which is carrying the negative sign. So this is automatically a b. That's what you have. And the relationship here is that for all the hyperbolas you're going to be looking at, c is the longest side. Yeah, so here we're going to have the foci is going to be the longest side because it's found inside here, right? So yeah, any points you try to connect, c is the longer side. So we have c squared is equal to a squared plus b squared. So this is a must. You must know this. Differentiate it from the previous one. The previous one, which is an ellipse, a, which happened to be the number which is down the major axis, either x or y, is the longest side. So it was a squared is equal to b squared plus c squared. But here, c, which is the foci, is the longest side. This is what you have. Yeah, so let me just give you a general case scenario for both the two cases that I've discussed here. So let me just write it neatly here. Yeah, so you have case 1. Yeah, case 1, when you have the horizontal axis. So the horizontal axis meaning it's lying on the x-axis, meaning it's like this. Yeah, so this point here, this is going to be your negative a comma 0, where it's turning from. Then this is going to be your a comma 0. That's the major axis. So these are the vertices, I mean. Yeah, so the foci here, you get the foci by just saying the foci is going to be here. So it's either negative c over comma 0, or rather c comma 0. So the foci is plus or minus c comma 0. And the vertices, yeah, still the same thing. Then you have this is the major, the asymptotes. Here, the asymptotes. These lines, there's a line here which is a positive one, then there's a negative one there. So the asymptotes for this guy, whenever I have a horizontal axis, is equal to plus or minus b over a x. And please don't forget that c squared is equal to b squared plus c plus a for this case. All right, even the other case, but for parabolas, hyperbola, I mean, this is what you have. So these are hyperbolas. We're dealing with a hyperbola. Yeah. Then for the other case, we'll just change this. The foci c will be this side, a will be this side. This is going to be a over b with an x. Yeah. Instead of issue an x, instead of b over x, we'll say a over b. Yeah. So for this case, let me just write it for the sake of those who are making personalized notes. Yeah, so we can have this case, it's turning up, turning down. We have the foci, which is going to be 0, plus or minus c, and we have the vertices, which are now going to be 0, plus or minus a. Then we have the asymptote, which is y is equal to plus or minus a over b, then with an x. So we have this. Yeah, this part there. So let me give you an example, rather two examples, on how we can deal with questions that have to do with this. So these are standard equations that I'm giving you. These guys here, this whole thing that we have here. These two equations. We can have general ones where you have y minus, let's say, h. Then we have a squared, then plus or minus. There's a minus here. These are hyperbolas. There's a minus. So there's a minus. Then you have x minus, let's say, k. We can have this. Yeah, where the center is not at the origin. So, so to say, it can be anywhere. So no wonder we're having this. Yeah. So please don't forget the difference between the asymptotes. It's only on switching a and b. Yeah, so let me give us an example. So I'll give us two examples. So they're saying find the foci, vertices, and asymptote of the following hyperbolas and sketch the graph. So we're trying to find the foci, the vertices, because they are, it's plural. Then we have asymptotes. Then we should be able to sketch the graph. Yeah, so I'll give us three questions, but that one is going to be yours to submit to see if you understand the topic, the conic section rather. Then B, we have y squared minus 8xy is equal to, there's a 2. Yeah. Yeah, then there's C. C has information, so the vertices are given. This is very straightforward. Okay, so there's a hyperbola with vertices, whose vertices are, so the vertices are the 0, plus or minus 1, and passes through the point, so passes through a point, root of 6, 5. This is root of 6. They're saying find the equation of the hyperbola and equations of the asymptotes. Yeah, so this is way easy, but I'll just like to see what you're going to do, so you can submit to me on WhatsApp 0978 73 90 38. Yeah, so let's just see what you're going to do. So I'm going to solve these two questions there. Yeah, so the first one, part A, we're having x squared over 8. So this is straightforward. We're going to have this on the x-axis because the number 8 is one that is having a positive, so this is positive. There should be a minus all the time. This is how we differentiate the equation of an ellipse and a hyperbola, because of the minus and the plus. So this means that a squared is equal to 8, implying that a is equal to 2 root 2. So you guys are second years, I don't have to explain how this came about. Then b is equal to 1. Then there's an equation that says c squared is equal to what? C squared is equal to a squared plus b squared. Okay, so this came about because I square rooted this, guys. Root of 8. Root of 8 is the same as 4 by 2. So this is the same as the square root of 4 is 2. Then the root 2 still remains. That's how it came about. Yeah. We're looking for c to get the foci, because x is the one that's positive. This is this case. This is the case we're dealing with. Yeah. That's the case we're dealing with. So according to that, we're going to place in our 2 root 2 a squared plus b, which is 1 squared. We're trying to find our c. Yeah. So our c squared is equal to, that's going to be 8. Then plus 1, that's going to be c is equal to 3, right? So if c is equal to 3, we can go straight ahead. A is 2 root 2, b is a 1, c is 3. Yeah, so we can sketch it. We have this. Our a is going to give us the vertices. So our a is here. We are having negative 2 root 2, comma 0. Or we have 2 root 2, then comma 0. Then we are having our c, which is what? Negative 3, or 3 this side. So our foci, can just go ahead, plus or minus 3, comma 0. Our vertices, plus or minus 2 root 2, comma 0. Then our what? Asymptotes. This is the case where we have asymptotes. Y is equal to plus or minus b over ax. So it's y is equal to plus or minus b happens to be 1. A is 2 root 2, then x. You can rationalize this or just leave it the way it is. That's going to give us plus or minus. That's going to be root 2 over 4x, I think. Yeah. This is what you get. So this is basically what was required. In the next one, so the next one is going to be equal to, let's say what, this is going to be part B, which is y squared minus 8x squared is equal to 2. Remember that we need to have 1 on the right hand side, so I'll divide everything by 2. That's the first step. So y squared over 2 minus, this is 4x squared is equal to 1. Then here now, I'll divide both sides by the coefficient. So that's going to be y squared over 2. Then minus, this is going to be already a 1. So I can just leave the 1 there. So I'm going to have x squared over 1 over 4. Then this is equal to a 1. So hope you're okay here. I explained the same thing previously. So we need to have a coefficient of 1. So according to this, our a squared is 2, meaning our a is the root of 2. Our b squared is 1 over 4, meaning our b is just 1 over 2. You can get your c. And because the positive one is on the y-axis, so meaning this whole thing is lying on the y-axis. So we're having this case, right? Yeah, so now according to that, I can remove this part. I had divided by 2 because you need to have 1 on the right hand side, so I hope you remember that part. Our c is what? A squared root 2 squared then plus 1 over 2 squared. That's going to give us a 2 plus 1 over 4. So c squared is equal to a 2 plus 1 over 4. That's going to give us what? A 4. That's going to give us 8. Then plus a 1. That will be 9. C squared is 9 over 4, which is the same as c is 3 over 2. Yeah? So 3 over 2. You can write the rest of the information because I gave you the formulas already. You know your A, your B, and your C. So you now just replace in the things that have to do with your foci. So our foci, for this case, our foci is going to be, since we're on the y-axis, right? The x-coordinate has to be 0, so that's going to be 0, plus or minus your c, which is 3 over 2. Your vertices, also you're on the y-axis, so your vertices are here, 0, your vertices are 0 plus or minus a, which is root 2, and you can be able to sketch this. Asymptotes, we said this is supposed to be a over b, yeah, plus or minus. We have 2 of them, the one that goes like this, the one that goes like that. No wonder we put a plus or minus. Yeah, so the plus or minus 2, that's a, which happens to be root 2 over b, which is 1 over 2. Yeah, you can just leave it there, or actually write it as 2 root 2, plus or minus. Yeah, so this brings us to the end of our conic sections. Just general information about conic sections. The next thing we need to do is classify them using eccentricity or the determinant, translate the axes, rotate to remove the x or y term to be able to determine the shape or how much angle it has been rotated if it's not at the origin. Then we'll end by parameterization of these planes, of these plane curves, or rather in 3D, in 3 dimension, and also add on how we can convert these x, y coordinates to express them, because that's like Cartesian form. Now I have to take them into polar coordinates, your radius and your theta, cos and sine. Yeah, so this is just a video on the conic sections. Then lesson 2 will be made available tomorrow as we discuss the last part of the topic, which is how we can do the rotation, translation, and everything else that I mentioned. Thank you so much. Hope you'll be able to submit the exercises that I was giving every after a conic section.